Alright, so we've been talking about energy, but one thing we need to talk about is something called power. It's going to be the rate at which we transfer energy. Rates are usually given to us by during some unit of time. So power is going to be energy per time. And when we talk about power being energy per time, power is given the letter P, and our energy is the rate at which we transfer the energy. So it's the change in energy per time. That's how we're going to define our power. This is energy per time. This is a joule over a second. And this is the unit of the watt, named after James Watt. And James Watt is the guy who starts studying the amount of energy it takes to move certain things. And of course, he's the guy that comes up with the definition of the horsepower. And 1 horsepower is 746 watts. So what this guy did is he was comparing, when he was looking at what a horsepower was, he wanted to be able to label like the strength of a steam engine. Like how much could a steam engine lift? So power is energy per time. But we've also said that delta E is the work done. So if you're doing work, you're having a change in energy. So work per unit time is the power that something is either delivering to some system, rate at which something is consuming energy. Because either you're supplying a certain amount of work per time, you're powering something, or something is absorbing a certain amount of energy per time, and then it's absorbing or using that much power, right? So power is either something you can deliver, it can be absorbed or used, right? Now the last way we can think about power, so this is like work per time, so it's like how much energy you're delivering per time in unit time. Either you're giving this, you're supplying this, or you're using this. And then the last thing we can think about is we said that work is force D, it's the force times the distance. So if you're having to power something, let's say, you're supplying a force to do this work to something, distance over time is velocity, so it's the average force that you apply to an object to maintain the velocity. So this is kind of like, oh, my car is going to drive at 55 miles an hour. If the average force that the engine has to exert or whatever means the engine supplying so much power to maintain your vehicle at that speed. So these are just 3 different ways we can think about power being energy per time. That this is the basic definition, that there's some change of energy in a certain amount of time, that's power. But because we know that an energy change is caused by work, that work divided by time is the power either being used by something or the amount of power being delivered to something. And then we can think about, because work is force over distance, the average force times the velocity, if it's a moving thing, that's how much power is having to be supplied to maintain that velocity for that given force.